Thank you very much, Mallory and others, for inviting me to participate in CRISPR-Con this year. My name is Ritwick Ghosh. I have a background in economics and sociology and science and technology studies, and I work on issues of environmental governance. So in a way, I am really hoping to learn and take away ideas from this meeting. And I'm hoping that some of my current work on the use of technology in producing public goods from private landscapes can be of use to the discussions here. So just to give a little bit of a framing, I work on environmental governance, and by environmental governance, I mean the interactions between the state, the market, and the community or the civil society. So in environmental governance, we often think about modes of governing, and the governance language sometimes can be understood as something that is not government, as we need more governing than we want government is something we hear sometimes. But in academic work, in sociology and economics, the way to think about governance is in blending the role of the state through modes of legal enforcement, the bureaucracy, the modes of the market through ideas of incentives and private regulation, and community, something in the language what Dr. Kaplan was saying about values, engaging values is in the world of community. Sometimes I like to map this up with the fear as the state, the market as in money, and the community as in love. And again, we are interested in the interactions across all three. In the environmental governance world, you can think about the Endangered Species Act, the Clean Water Act, pesticide regulation, K4 regulations as examples of the state. We can think about emissions trading, carbon offsetting schemes as something in the realm of the market. And we can think about common pool resource management, ideas of land trusts as in the world of community, although these three are constantly in interaction. My interest relevant for CRISPR-Con is really about using gene editing technologies to capture carbon on farms. So how do we augment the photosynthesis capacity of plants in order for them to capture more carbon dioxide from the atmosphere? There are a few ways I would approach this. One is about the intended consequences of these projects. There are going to be benefits, carbon benefits, sequestration benefits, but who do they accrue to? One of the major challenges in promoting sustainable agriculture has been that the benefits, the environmental benefits of sustainable agriculture often accrue beyond the farm. So water quality benefits, for example, may accrue beyond the farm. So the key challenge then is that this is not a private good and that farmers may not have the incentive to invest in the technology. They may need financial support and technical knowledge support in order to engage these technologies. The second point that I want to make is about unintended consequences. And when we focus specifically on technology and carbon, we may miss other environmental issues. So for example, my work in India and carbon forestry is showing that in search for carbon sequestration through trees and nature-based solutions, we may be forgetting local ecosystem benefits and who they accrue to. So it's important to keep the unintended and the intended consequences in mind. My current work at the New Carbon Economy Consortium is much to do with nature-based solutions as a term which has become important today, but has been around, as the concept has been around for many years, is the idea of using ecosystem management to produce and sequester carbon. I would like to look at some of the ways in which we have thought about carbon sequestration on landscapes in other ways, and the institutional structures already in place or innovation that have been attempted in order to have landowners, farmers engage these new technologies and new solutions. I'm going to skip this slide. So I'm going to give you three examples from my work. One is in the climate conservation stewardship program. This is one of the largest conservation programs in the US Department of Agriculture. And the basic idea here is to pay farmers to produce ecosystem services. So they take on certain practices like cover cropping, which sequester carbon. So if you have to think about farmers adopting certain kinds of new cropping systems or buying new genetically edited seeds, we can think about some of these ideas about the conservation stewardship program as ways of vehicles, of mechanisms to be able to reach out to farmers. The conservation stewardship program is one of three or so major environmental programs. And in 2012 or 2009, really, when the law was passed, they introduced a way to target farmers. So they used an environmental scoring algorithm, which which ranked every single applying farmer based on the expected environmental outcomes they would produce. They would rank them and only select the highest scoring farmers. The idea was that we have more money than we can enroll every single farmer or applying farmer. So why don't we be selective? The problem here is that the technology that was used was a very complicated environmental scoring algorithm, but it worked through the NRCS, the Natural Resource Conservation Bureaucracy, and was somewhat secondary to the functioning of the bureaucracy. So yes, there was cool digital technologies that were applied here, but really they were subordinate to the functioning of the bureaucracy, which was necessary to make this program work. So at the end, what we had is a digital innovation, but one that produces very little actual change in the allocation of resources and incentives. So then what was the point of it is an important question to keep in mind. Another example I'd like to give you is of the Climate Action Reserve, which is a standard setting organization in California. In the early 2010s, they started developing something called a nitrogen management protocol. This may be of interest to those, especially in the agricultural world. And the idea here was that the Californian, a robust functioning Californian carbon market, could create financing for offsetting some of the emissions in California by incentivizing farmers in the Midwest or anywhere else in the country to adopt certain practices that sequester the nitrate or reduce nitrous oxide emissions from their farms, mostly related to fertilizer application. They wanted to do something very precise, that at the farm level, they can differentiate how much in nitrous oxide emissions have been reduced. They produced a protocol in 2013, and then they redid the protocol again in 2016. And last I checked, which was a couple of months ago, there has only been one transaction on this specific protocol. And this transaction really is also through Indigo Agriculture, and really is not focused. I would argue that it's not trying to maximize Indigo's revenue, but it's motivated from other interests. So it's not a market-based solution. It was really a community-based solution where Indigo is approaching it from a sustainability or a community perspective. The point here that we can produce really interesting standards and technological solutions, but there might be complications in getting those solutions to the farmers and actually producing change. So what exactly is the theory of change here is something that we want to keep in mind. Very briefly, I'll talk about Tembu, which is a open source environmental data service company out of New York City. And one of the major projects, they got a lot of high profile recognition earlier this year when they were featured in the New York Times. And what Tembu does is sets up sensors all across parts of Brooklyn and other parts of New York, which provide information about storm water absorption by the soil. And the main conclusion some of the innovations have led to is that having trees planted in the city can provide useful ecosystem benefits. I would argue that using NCD sensors and Raspberry Pi tools, having an open source data are all useful, but we already kind of knew that trees are useful for managing carbon and managing water in a city. So what did all this cool new digital technology and sensing and remote sensing and open source data offer the environmental movement? And not to be too critical of these ideas here, but that we need to keep in mind that what is the theory of change? Where do we go from the actual implementation or the actual source of the idea to producing benefits in the future? So just to wrap up my ideas that having worked in the conservation world And in the environmental world for about 10, 15 years now, I used to work with the UN environmental program before this. I'm quite aware of conservation fads. And it is important to be aware and overcome the fad momentum, which is that we come up with new technologies, new ideas, they go away, they don't really produce benefits. We come up with new technologies, new ideas, new terms for the same ideas. And this is a real momentum in the environmental world, producing very little or very non-scalable changes. Second point, Dr. Kaplan mentioned values in science, and I think we need to keep in mind money and incentives as well. Human behavior changes with a sense of community, sense of values, sense of government rules, but also finances and incentives are important for motivating behavior. So who will pay for these ideas and why will they pay them? And sometimes in the why they will pay, the government becomes an important player because the government can regulate actors to make them pay. It's also important to think of not just technologies, but infrastructure. My project on the conservation stewardship program shows that you created an algorithm, but to make it implementable at the level of single farm in, say, North Dakota, where I did a lot of my research, required a local expert and somebody with local buy-in. And that was often the street level, what we call in public administration, the street level bureaucrat. The last mile of the technology is important. And that requires us to think in terms of infrastructures, not in terms of technologies. And finally, one major challenge in environmental governance is something that the economist Jevons pointed out in the 20th century, is that we can create more efficient ways of producing goods and services. And efficient here being that they can sequester carbon without and produce goods and services at lower and lower environmental impact. But if we continue to produce goods and services at a higher rate, overall total production of environmental harm in the economy continues to grow, even if the environmental harm per unit of production goes down. So it's also important to keep in mind that the political economy around production and consumption is very strong. And so which kinds of production and which kinds of consumption are worth the One Health or future challenges that we might be facing is important to keep in mind. And this is a question not about technology, but about political economy. Thank you very much.